Wave equations, calculation practice, section 10 of the pink booklet. Wave equation, well, wave equation is velocity is equal to frequency times wavelength, f times lambda. Time period here is t, capital T, over 1 over f, 1 over frequency. So, low demand questions first. Calculate the speed of sound wave with a frequency of 150 Hz and wavelength of 2.2 meters. So, in a box, what we need to find, underline the data, write down that data. So, speed is velocity, we have a frequency of 150 Hz, and we have a wavelength of 2.2. So, formula. Velocity is equal to frequency times wavelength. Insert. So we've got 150 times 2.2, which I believe is 330 meters per second. Number 2. Calculate the speed of light wave with a frequency of 7.5 times 10 to the 14 and wavelength of 10 or 4 times 10 to the minus 7. So calculate the speed. And that's speed, velocity. Now, what we've got then is 2 bits of data, and this is where the real big problems lie when you're doing wave calculations. You've got very big numbers, well, this frequency is 7.5 times 10 to the 14, and very small numbers, like the wavelength, incredibly small. In fact, I think the coronavirus is a little bit smaller than this, in fact, which is why it doesn't have a colour, because it's smaller than the wavelength of light. So anyway, quite interesting really. So frequency, velocity, frequency, wavelengths. We've got frequency, and that's 7.5 times 10 to the 14. Very big. Velocity, 4 times 10 to the minus 7. Minus 7 meters. Okay, write down my formula. V is equal to frequency times lambda. Insert my numbers. I'm putting brackets around these to keep them separate. 7.5 times 10 to the 14 brackets times 4 times 10 to the minus 7. So our answer to this one then is, well, it's the velocity of the speed of light. So it's going to be 3 times 10 to the 8 meters per second. And you put that in your calculator and find that out. So, number 3. What's the frequency of a wave with a time period of 4 seconds? So, frequency. So we've got frequency f. We've given time period is 4 seconds. We know that t is equal to 1 over f. Insert my data. 4 is equal to 1 over f. So if I rearrange that, I'm going to see that frequency is actually equal to 1 over 4, which is 0.25 Hertz. Number 4. What's the time period of a wave with a frequency of 10 Hertz? So time, we don't know. Frequency is 10 Hertz. And we've got time is equal to 1 over f. So we insert t is equal to 1 over 10. So our answer is 0.1 seconds. But you knew that already, didn't you? So dead easy. So now we come on to some more difficult, tricky questions, the standard demand questions. Let's wait for that to focus. So question number 4. Write down the wave equation. V is equal to frequency times lambda. So now what is the frequency? So f. So now I need to underline. There we go. So we've got speed, velocity is equal to 3 times 10 to the 8 meters per second, and a wavelength of 1500 meters. So what is the frequency? So write down my formula. V is equal to frequency times lambda. Insert my data. 3 times 10 to the 8 is equal to frequency times 1500. So if I divide through by 1500 both sides, then that will make f the subject, so it's 3 times 10 to the 8 divided by 1500, which gives me an answer of 200,000 hertz. So what I'm going to do is I'm going to turn this into kilohertz. So I'm going to divide through by 1000, and I'll get rid of these 3. So that leaves us with 200 kilohertz. Okay. Now number 5, write down the wave equation. What is the speed of a wave? Calculating speed. So with a frequency of 150 kilohertz, that's 150 kilohertz, which equals 150 times 10 to the 3 hertz, and a wavelength of 2 kilometers. So 2 kilometers, which is equal to 2000 meters. So V is equal to frequency times lambda. Insert my numbers. So that's 150 times 10 to the 3 multiplied by 2000, and that gives me an answer of 3 times 10 to the 6. Well, sorry, 300 times 10 to the 6 meters per second, which is actually 3 times 10 to the 8 speed of light. Now moving on to number 6. A wave has a wavelength in a ripple tank of 5 centimeters and a speed of 2 meters per second. What's its frequency? Frequency is equal to, we don't know that one. It's got a wavelength of 5 centimeters, which equals 5 times 10 to the minus 2 meters, and a speed, velocity of equal to 2 meters per second. So, formula, velocity equals frequency times wavelength. Insert my data. 2 is equal to frequency times 5 times 10 to the minus 2. So, now I need 2, divide through by 5, divide both sides by 5 times 10 to the minus 2 to leave f as a subject. F will equal 2 over 5 times 10 to the minus 2, and that will give us an answer of 40 hertz. So a wave in a slinky has a frequency of 0.3 kilohertz and a speed of 1.5 meters per second. What's its wavelength? So lambda, we don't know. It's got a frequency of 0.03 kilohertz and a speed velocity of 1.5 meters per second. So this 0.03 kilohertz is 0.03 times 10 to the 3 hertz. So formula, V is equal to frequency times wavelength. Insert my data. So 1.5 is equal to 0.03 times 10 to the 3 times wavelength, divide through by 0.03 times 10 to the 3, and that will give me 1.5 over 0.03 times 10 to the 3, which in actual fact is 0.05 meters. There we are. So, right, number 8. Okay, high demand questions. So, a student investigating water waves in a ripple tank and count 20 waves past a fixed point in 10 seconds. They measure the wavelength to be 8 centimeters. What's the speed of the wave? So velocity, we don't know. We've got the wavelength of 8 centimeters. So 8 centimetres, that's 8 times 10 to the minus 2 metres, and we've got 20 waves, okay, 20 waves past a fixed point in 10 seconds, so that's 20 waves in 10 seconds. So this gives us a frequency, okay, of 2 waves per second. Quite simply, 20 waves per time, number of waves divided by the time, and that will equal 2 hertz. Okay, so that's our frequency. So now we want to calculate speed, so velocity is equal to frequency times wavelength. So we've got to insert, so frequency is 2 times wavelength, which is 8 times 10 to the minus 2, which will give us 0.16, and its speed, so it's meters per second. So, the time, number 9, a time period of wave in a string is 0.4 seconds. There's a wavelength of 2 centimetres, what's the speed? So velocity, I don't know, but I do know that it's got a wavelength of 2 centimetres, which is equal to 2 times 10 to the minus 2 metres. Now, time period, so t is equal to 0.4 seconds. Now, v is equal to frequency times lambda. I haven't got frequency, but I've got time, the time period. I do know that frequency is equal to 1 over t, so that is equal to 1 over 0.4, which I believe is 2.5 hertz. So now, velocity is equal to frequency times wavelength. Frequency is 2.5 times wavelength, which is 2 times 10 to the minus 2, which is going to be 0.05, and we're finding speed, so it's meters per second. So I'll find my calculator and check that last one. .5 times 2 times 10 to the minus 2, and that will give us 1 over 20, yeah, 0.05.